What are pulsars and what's the difference between neutron stars and magnetars? So I just explained what a pulsar is. Now, what is the difference between neutron stars and magnetars? So let's start with neutron stars. A neutron star is a core collapse remnant of a is the remnant of a supernova, of a core collapse supernova. So typically you have a neutron star is formed after the supernova of a supermassive star, a star that is typically between 10 and 25 solar masses, a supergiant star, right? So when a supergiant star reaches the end of its life, it essentially stops burning fuel uh, and in a fusion reaction. So it typically happens when you have the formation of iron in its core. That's when the fusion reaction stops, because iron is not nuclear fuel, it is nuclear ash. So the moment iron is formed from fusion, so fusion happens by the fusion of two nuclei. Hydrogen nuclei form fuse together to form helium, and then you have heavier elements that are formed. You have you have oxygen, you have carbon, you have neon, and then it reaches the stage of iron. And once all the neon is used up and you reach iron, that's when a star is essentially dead. It has just a few seconds of life left, and that's when stellar collapse happens. And after the collapse, when the star starts imploding, the core of the star is really compressed very, very strongly, and protons and electrons combine and form neutrons. And so the core becomes just formed of neutrons, only neutrons, nothing else. And then the supernova happens with whatever material is left in the star. And at the end of the supernova, what is left behind at the center of where the star once was is a neutron star. So a neutron star is typically a small star between 1.4 solar masses and around 2 solar masses. Anything larger than 3 solar masses, it will become a black hole. So that is what a neutron star is. It is the most compact and dense object in the known universe, apart from black holes. So that is what a neutron star is. It is composed almost entirely of neutrons. Now, what's a pulsar? Like I said, a pulsar is a neutron star which spins very rapidly and gives off two beams of electromagnetic radiation, typically radio waves, in two opposite directions, and it pulses extremely in a very periodic manner. What is a magnetar? A magnetar is again another neutron star which has an extremely powerful magnetic field. So the magnetic field of a magnetar is typically hundreds of millions of times stronger than the most powerful man-made magnet available on Earth. It's an extremely powerful magnetic field. It is trillions of times more powerful than the magnetic field of the Earth itself. Now, it is the evolution and decay of this magnetic field in a magnetar that gives off extremely powerful bursts of radiation, typically in the X-ray and gamma ray spectra. And this is what's known as a soft gamma repeater. So this is the astrophysical source of the phenomenon known as the soft gamma repeater phenomenon, right? So that's what a magnetar is. It is a neutron star with a very, very incredibly powerful magnetic field. These are incredibly interesting, fascinating, and exotic objects. And this is the kind of phenomena that the laws of nature throw up.